Hello, everyone. Sanjin here with Stuffy, and we're doing another set of picoCTF walkthroughs. Today's topic is going to be web exploitation. Before we get started, just some general guidelines, ground rules. So please try every challenge yourself first. As much as it would be good for the YouTube algorithm and for us, for you to watch this video in one go, actually the idea here is that you try to solve all the challenges and then come back to see a solution maybe that you couldn't find, or a solution that's done differently. The other thing is, when you're solving these, do not be afraid to be stuck. If you're stuck on a challenge for an hour, hour and a half, you're going to totally prime your brain to like fully engage with, understand the solution, and most importantly, remember it. You don't learn much from challenges you find easy and just sort of click into, right? And yeah, finally, I guess this is what the video is going to be good for. I'm a relative beginner at cybersecurity. Stuffy is an experienced hacker, and we'll come at these problems even ourselves from different perspectives. And most likely, if you come back to see how we did it, it's going to be something different, and you're going to learn a new angle to it. Okay, so let's get into it. All right, Stuffy, here we go. For you, these are a bit fresher. I've solved them about a week ago. So get ahead. That is the first one. Finding the flag being held on the server to get ahead of the competition. Hints are maybe there are more than two choices, and use tools like Burp Suite to modify requests and look at the responses. Okay, so headers.
So did you use Burp Suite to do this one?
Yeah, I used, I'll open up Burp Suite, and I've used Burp Suite for all of them. I guess
you actually don't have to on this one, but.
Oh, really?
Yeah, you can just curl the headers. It's pretty common that most people look for headers when they look for, when they're first doing some very basic recon on a website. They'll pull the headers. And the reason for this is simply the headers contain information about the site, but it won't display. That's the whole point of it.
So trying to, let's see what I did. This is what I generally do. I go into the proxy, I turn on the intercept, I open the browser, which is sort of the Burp Suite built-in browser, so you don't have to install proxy on anything. I think the website was here. And then I forward. The repeater is the best because I think you can just sort of see the request and the response. And from memory, and see there are, what types of requests are there? I think I've had a link, and this was from my notes when I did it. There's a number of different types of HTTP requests that you could do. And this was a list of them. And one of those requests is a head.
You'll see post a lot as well. And that's because, so the way website design works, I'm not sure how familiar you are with website design, but basically it uses the JavaScript to run usually it's input. So if you're logging in or something, and the script tells it once it's a post request, it tells it what to do with that information. So if you input, your username and then password, whatever, it will then send a post request that then the script specifies. So if you're trying to get the backend script to do something, a lot of times you'll have to change it to a post request, or if you're expecting it to give you information, a lot of times it'll be a post request. That the head obviously is going to give you the header.
Right. And okay, so first of all, here it is. I'm probably going to get the flag here. Yes, I do. The question is if you have to describe it, what exactly is a header?
It's so to kind of break it down, the way a website's designed, right, is it used to be just written in HTML. That's not how we do things anymore because it would be a nightmare. So what they use is now CSS and JavaScript. So CSS is cascading style sheets. So
Mhm.
what that does is that formats everything in your website. So like for instance, you see all the text in Pico's website is gray, right?
Mm.
Well, instead of them having to go to each field and change that, they can go to their cascading style sheet and they can just change text and change the color, and it'll change everything on the website.
Provided, of
So
course, provided that like the stuff that you're changing has a tag. Otherwise, you have to add a tag.
exactly. Yep. It's usually broken down by tags, correct. So
Yeah.
that's how the CSS works. And then JavaScript tells it what to do, how to handle inputs and different things like that. And usually it's reaching out to a database or whatever it's trying to do to compare usernames, accounts, stuff like that. So the header contains that information. And the
Mhm.
reason it does that is so that it's not going to display, but at the same time, like web crawlers and things like that can find that information, which might sound nefarious or dangerous, but it's actually useful because you can put in like title of your
Mm.
website and stuff like that, and then Google can find it. So it's a way to get the basic information you need for a website out to web
Ah.
crawlers, Google, that type of stuff.
Right, right. So like it's almost like a little bit of data for search engines, but also
Yep.
like here it says text type HT. Like, is this a part of the header? This content type field? This
Yeah,
is in
it's
the
just
header.
that'll be in almost every header, but yeah, so it's just explaining what kind of content's in it. But at the same time, it's just a way to tell whatever client server that's interacting what to expect.
And this first line, it says HTTP 1.1 200. Okay, it's kind of like, yeah, I got the same version of the thing that you
Yeah.
requested.
So that's the error code, even though it's not an error. So like different error codes will tell you if it's a server issue, a connection issue based on the client, that type of thing.
Cool. All right, we are one down and 9 to go.
So yeah, so that was the burp suite way. I can show you the way
Oh,
that
yeah,
I did
yeah,
it if
yeah,
you'd
yeah,
like.
yeah.
So all you got to do is just right there, just type curl.
Curl.
Yep. So this is going to reach out to the site. Now
Mhm.
the dash capital I, and this is
Capital
going
I.
to tell it. Yep. And then all capitals HEAD. This is just telling it that you want the head. Same as like the get or whatever you in the posts and stuff that you changed in there. And then lowercase I and then the website. And this is
Okay. Wow.
you'll have to put a dash in front of the I. I'm sorry, the lowercase I.
Attack I.
Yep,
as you
attack
call
I.
it. I hope that's correct because now I'm calling it attack I. And I heard it
That's
from you.
how every technical school I've ever been to has said that.
Okay.
That it's
All right.
attack. I don't know if it is, but that's what I call it.
Cool, cool.
And then there you
it
go.
is.
So you get the header.
Reject the duality.
So a lot of people will like for me, so like one of the first things I teach people when they're doing OSINT and stuff like that for just websites is I'll teach them very basic information gathering that's all public, right? The header's public, you're not doing anything wrong. And so I have like personally, I have people create or students create a script that will do like a NS lookup, dig, tracer, all this stuff, curl, the header, all this stuff, and then basically compile it into a report for them. And I have a script that does all this in a matter of seconds. So that's usually something that it's, even though you may not get a lot of information from it, it's nice to see because you know what to expect. And then every now and then you might get lucky and find something in there.
Right. I'm sure that there's like, if this is what you teach students, I'm sure this is like an automated tool that basically does some type of threat analysis for a website, right?
Yep. Yeah. Usually a large organization is not going to have any information in the header that's nefarious, but you never know what you'll need or what will be helpful until you've actually done a lot of pen tests and found little bitty things that you didn't think were helpful, but then they are.
There is the container and it's really panel margin. And funnily enough, like I'm teaching this at like a year 7 level right now. And this is like my worst aspect of coding. I'm best with like embedded devices, microcontrollers, and then like general purpose languages and HTML. I am a relative novice. So yeah.
You can see like so right there's the action is index.php, method is post. So if you sent that action, that submit button or the choose blue, whatever, if you sent that in a get request, it wouldn't do anything with it. So the post says use whatever script they specify to do what it's supposed to do, which is in this case, change it. So,
and I'm just trying to look for the exact, like where the button is defined and where the actual text for the button is, panel buddy, but I can't see the actual choose blue words, but not that it really matters at all.
That's also, so sometimes what the problem with HTML is a lot of coders, especially HTML coders that use what we call templates and things like that. They actually allow the browser to finish the code for them. Right. So a lot of lazy coders will do that. Or if they don't know, if they're just not that good, they might leave things out. Then obviously the web browser will try to finish that for them. So that sometimes causes code that doesn't make a lot of sense, because a lot of times, so there's your get, choose,
there's the get. So there's a method get, and there's a type submit and value choose red. So like we can actually write a get request that says choose red.
Yep. And well, you can see, so I think when you go to the website, it starts at red, right?
Yeah.
So now watch, if you just did Burp Suite, instead of clicking choose blue, if you change it to post, I think it changes to blue, because if you look down at the form action method post, I think that's the only thing changing it to blue is sending a post request.
Wow.
So just change that head to post. Now that's just what I just looked at the code, so we'll see if that's right.
Render.
Yep.
It's interesting because it's not blue or red. It has changed the layout, and now it's not color. Oh, it said PSD. I could be wrong. Post send.
We'll see.
Yeah, you're right. You're right.
So just they had a get request, changes it to red, a post request, changes it to blue.
Interesting. All right. Well, we really well and truly crushed that one from 2 angles.
Yeah.
Let's look at the cookies. So who doesn't love a cookie? Try to figure out the best one. Now, I'm trying to remember. Let's see this in action. So, we've got the inspector on from the get-go. So this thing is doing.
The thing I like about this one is if you get the right cookie, you can actually get it without ever having to do anything. If you can guess the right cookie.
Right. And it's got names of cookies, right? So like,
they're all,
and I mean, categories, sometimes that there is some level of checking that's in the actual, is this called client side code? What's this called?
Yeah. So the problem is, like I said, in the section you're in, this isn't the actual raw code. This is the elements that the browser itself does. So a lot of times what people will do is view page source, which is the actual code, and then look at it that way. But this is a good tool if you're trying to troubleshoot that type of thing. But the raw code will tell you a little bit more, like if the browser finished something for you, things like that. But yeah, it just depends on how the website's built, whether it's client side or server side. That I think we cover one that's actually says
don't use client side.
Yeah, don't use client side, and you'll see why.
And I mean, this is look at what is this? It's like a JavaScript program written in one line. So you kind of get these things that are purposefully convoluted and hard to understand. So let's just go back to this thing, and they give us no hints. Who doesn't love cookies? Try to figure out the best one. So I believe I started this by just doing the same thing you've seen me do earlier, going back to the proxy, opening the browser, going to that website. I think this is the new one. Yep, forward that. Let's go.
And there's obviously hints involved with all these, so.
Why are you taking so long? Cool.
One thing I can tell you too that I use Burp Suite a decent amount, and just a way to save. I've never used the Burp Suite browser, so that's new for me to see. I'm glad you use it. But one thing I always do is under target, I will always put the target that I'm requesting And that way it will always get rid of any other information in there. Because obviously when we're connecting to the internet sometimes, but when you're using the browser, you can type it in directly. But if you open up your own browser, you'd get a bunch of requests and stuff from just going to Google and everything else.
Right. So if I go into target,
Scope.
That one, I think this is, we're using the 529 right now. So
Yep.
if
I always just add it to scope. Yep. And then you don't have to do this every single time. It's just something that is good to do, because especially when you get, if you actually are on a pen test for real, you cannot step outside your scope. So they may say you have these servers and you can't step outside of that. So if you do capture something on accident on the wrong server, you have to report that. It doesn't look good for you, everything else. So
this I found interesting, right? So you render that, and but it says like cookie name equals to -1, and then if I was to say name equals to snickerdoodle, and I send that, okay, so I would need to basically intercept the request. If I enter the name snickerdoodle, I would need to intercept that request.
I think that's the request you intercepted. I think the -1 is snickerdoodle.
Oh, okay. Let's all right, let's close everything. I've got like 6, 7, 8 things open. I need to just, can you tell me what's going on? Like I keep closing them and there are these tabs. Is this something wrong? Like
you just have 14 open, I think.
No, but every time I close one, an extra one pops up.
Go to proxy. It's intercepting. Just drop everything. Just click drop over and over. It'll drop. Now you can go to the repeater and close it.
Okay.
If there's anything there, there's nothing there. It's what you're doing is opening a new one every time, because there has to be something there.
Okay.
It doesn't actually take a packet until you forward one on.
So if the intercept is on and we have this,
you can just hit refresh. Yep.
We have the actual website. So by the time, if we request the website itself, just the actual address, that I think said name equals 1. Let's just do that again. I'll refresh it.
Yep.
Look at that. It does say name equals 1. So that's
okay.
not.
So yeah. So this is what I would typically do. If I saw this, I would type a name, capture the request, and see what that cookie name changes to see a pattern. So you're looking to see if there's a pattern. Typically, you're not going to actually get the pattern they have here.
Right. That's cookie name equals to, but then it adds that. Interesting. Yep. So as the name equals, it remains the -1. If I forward that and I forward,
try and change it to a that's a session ID, but try to change it to
snickerdoodle,
an actual cookie name. Yeah.
All right, snickerdoodle.
Because it just added that name. It didn't recognize it as the.
This is a bit annoying. Intercept off.
Yeah, this is typically why people use repeater, so you don't have to keep doing this.
Right. So now I'm going to enter snickerdoodle. Intercept is on. Name snickerdoodle. Name equals -1. So I mean, I guess this is, my instincts were to just shift these numbers.
That's correct. Yeah.
And the thing is, if I go to center repeater, and we're in repeater, and now I'm going to try.
So get rid of that name field, because it's probably going to. Yeah. Okay. So now try and send it here.
And I'm getting. Do I have even an error code?
You may have captured the wrong packet. So
okay.
This is why it's kind of a pain to use. So before you get rid of anything, you don't have to get rid of anything. Go to proxy and then go to history, HTTP history up there. And then look for the one. So the search redirecting So that's got to post. The one right before the search down on 14. All right. So this one, if you scroll down,
it renders.
Yeah. So send that one to repeater.
Okay. Which is send to repeater.
Yep.
Cool.
Now go to repeater. Now try and change the cookie name and then send.
How did you know to pick this one? I'll go.
Because it was right, but it's the one right before the request. So we want to send a request to change the name. So we'll see. See, you're getting a redirect, which is not what I got before. Try to change the cookie name to like 5. I just know that it goes up. I want to see what it does. So just hit send again. Okay, so it's redirecting. So we'll need to capture the redirect packet. So go back to proxy, or actually, I'm sorry, go back up to repeater. That's why we didn't. You got to follow the redirection up there. So there you go. It says, I love peanut butter. So 5 is peanut butter. So we just had to follow the redirection.
Like, you know what was interesting? So I did not know much about the redirect. I quite simply repeated the process of requesting the cookie like 3-4 times.
Over and over, yeah.
And then when I started to get real results by changing these numbers, that's when I sent it to the intruder and did I think it was a sniper attack or something.
Yep. Yeah, you can do all kinds of them. This one.
Oh, can I send it to the intruder from the repeater? Like that? Action.
Yep.
Send to intruder.
Yep, it'll just send that packet.
In the intruder, see, we got the name is 5.
And you notice it auto found it too.
That's yeah. And then in the payloads, it was, I just did numbers and I did from -1 to, I started by 100 and the step was 1.
Yep. This is why Burp Suite's so nice.
And I think behind our photos is the start attack thing here. Yep. Now, there's one thing that highly sort of annoyed me, right? Like, we're looking for variations in, first of all, what is this length thing? I mean, I've seen your videos. I've seen other people's videos. We need a deviation in this length or a different error code. And that's what we're going to check out. But like, why?
So typically this one's a little different because each cookie is literally different. So there is going to be deviation, right? Because peanut butter cookies is a different length than
is this the length of
the
bits?
packet of the packet itself. So that's why we typically look for a different length, because usually you're doing the exact same thing over and over and over, looking for a different result, right? So like for instance, if you go to look for a password, right? You're going to type in a website. Like for instance, you're noticing now you're getting 557 length after 30. What that tells me is they're no longer coming back with that, oh, I love snickerdoodles, blah, 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 because that's adding a bunch of length. They're now just saying that's not a cookie or whatever. They're giving you the exact same result. Yep. They're giving you the exact same result over and over and over. I can tell you, the 1265, that's a big one.
Deviates the most, right?
Exactly. So you're looking for deviations is all you're looking for. Typically, when you're doing something like this, you're not going to get slight deviations because it's very rare that a website gives you an error code that deviates, that says, oh, try this password again, try this password. It's going to be the same error over and over and over. And then one of them will work, if that makes sense.
And we'll render that. And there it is.
There you go. Yep. So the size is just, you're looking for deviations because you have the expected result, right? The expected result is we like peanut butter blossoms or whatever, but those aren't the cookies we're looking for. That's the expected result. So if you get that 20 times, but then one time you get a much shorter packet, there's a reason for it.
If you render it here, you can't copy and paste. So I better get it from there and then I can Control C. Cool. Now I know what the length is. So it's the length of the packet in bits. And that actually helps me a lot. Excellent. 2 down. So inspector written in is there a term for this? Like funky font? What, you know, like I see this in a lot of sort of hacking related, it's just,
it's just for effect.
yeah, I know.
I don't really mess with it. I see like a lot of people's like Twitter handles that are hackers have all that stuff. It's not that important to me, but
how do you inspect web code on a browser? Cool. I mean, look, all we got to do is there's 3 parts: inspect code on a browser. This was actually, this was not too bad at all. I'm going to full screen the thing. Actually, I'll copy this link. And they sort of give it away. I mean,
yeah,
you inspect element, inspect, ding, 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 ding. So there is heads, body, and I don't think I found anything. So I was expecting, you know, like maybe, you know, head, body, HTML to be 3 parts, but it wasn't. And then it must be, then I immediately knew that wherever it shows like HTML, CSS, and JavaScript, there we go. HTML, CSS, and JavaScript. So this JS. Oh, part 3 of the flag. So that could be part 2 somewhere.
There it is.
But where's HTML? Is it index here?
It was in the, you saw it right there. Yep.
So you got part 1, 2, 3. I really don't. I mean, I like the challenge. I find it funny that it's probably got a very high rating, 87%.
Yeah.
Everything that's easy is highly rated, which I kind of go like, guys, you know, give me a challenge.
This one, I mean, it's an easy challenge, obviously, right? But I think the point of it is to understand how HTML websites are built now. They want, because almost every HTML site nowadays will have a CSS cascading style sheet. They just will. Very few websites are built differently unless they're built with some sort of program. There's a lot of applications out there that'll build sites for you, right? And then a lot of them have the JavaScript if they're going to have any sort of input or anything that they're going to handle on the back end. So I think that's really the goal of this challenge, but I do agree. You could have added a little something with it.
Yeah. Given that like there's others that I've done in it, like there was that have like 5 steps. So True Detective or Just Lucky. I mean, I would say in this one, I was what? No, it was in the pasting.
True Detective or Just Lucky.
Yeah. picoCTF. And I think there's no other way to type in true. Yeah. Like,
yeah, I like picoCTF. The site itself, I do like it. It's just, I don't understand their scoring and things like that, because the really hard challenges just kind of seem to be intermixed. There's no like, it doesn't get progressively harder or anything like that. It just seems like there's very hard ones and then there's very easy ones, and they're just all over the place.
You know, I'm gonna, at some point I'll be contacting them with some suggestions and offering maybe to like rescore some of these. Cause I think that's probably like, if only that was done. Because look, I have a little bit of an insight into like minds of students, and there's a big variability in sort of resilience to failure. You know, like I actually had because I got parent teachers today. I've got like a thing of like 8 sort of habits of mind, right? That are really good for students. And one of them was responding to failure, being relaxed or sort of inquisitive and curious when failure happens, right? Because some of these things, when are really, really hard, you can have students that are really frustrated and get depressed, or you could be like, oh, really? That's interesting. That's so interesting. I wonder why, right? Yeah. And you kind of, if you have fair ratings, you're not going to get that upset if you're attempting something like you've been solving things at a 50-point level and you're attempting a 200.1 and you can't do it. You'd be like, okay, well, maybe I can't do 200s yet. But
or you would understand that you need to spend more time on them and things like that.
But if you're one of those kids that like gets upset in the presence of failure, which unfortunately is quite a few, then if you've been crushing the 50-point ones and now there's one that's completely impossible, you're going like, oh no.
Yeah.
All right, we are scavenger hunting now, and this is another website with one hint. Enough hints, really. The hint is that I should have enough hints. Thank you very much.
The hint itself was not a hint as much as a suggestion, in my opinion, because it says don't use a brute forcer. The reason it does this is because pretty much most of these sites, just to let you know how like a pen test would start, or how someone would start enumerating, right? I would use a tool like Dirbuster, GoBuster, and I would just start off finding all the directories. I would map this site out completely. Before I did anything. So that's what they're saying, because you would find all this just running an automated tool that tests the directories versus normal known directories. So that's why they're saying that. I feel like.
Is there a tool? I mean, this would be the ultimate cheat, that basically searches for strings in a website, like that I could just write in picoCTF and then it searches for strings in a website, because that would be
Google Dorking does that. Yeah.
Okay. Like we could touch that a little bit, and maybe on one of the last ones, maybe next week, because I don't want to show that to students too soon. I used to make so HTML, CSS, and JavaScript. This is definitely the one, right? 50.
Yep. So there's our first one.
Pico 5080 copy link address.
You were looking at the first one there.
Okay. Yeah. Here's the first part of the flag. Cool. Very nice. It's a comment. How come I can't? I guess if I go into sources, that's going to be in the index. Yeah, it is. So, all right, we've started. So scavenger hunt, that's the first part. No way, it's not going to be the same as, how can I keep Google from indexing?
They start giving you a little hints.
Okay. And this is, I did a little bit of research, and there is a file that asks Google to ignore particular subpages? Is it particular the robots? .txt?
It can be a lot of different things. So the whole point of the robots.txt file was security related initially, but it also has, nowadays people know about this. So it's not like it's hackers aren't going to find this, right? They're not really trying to hide them from you. They're trying to hide them from people that do basic Google searches, for one. The other big thing is, if you don't want like Google to literally list every picture you have on your page, every audio file you have on your page, because people will never get the actual content they want, right? When you Google for, how to do something, right? How to change your oil in your car. You don't want 5 million resources to pull up that are like just pictures of someone changing an oil, or just an audio file of someone talking, but that website's built by all of that put together. So most people will list like their CSS, their cascading sheets, they will list like their audio files and stuff, because all those are still on the internet, but they don't really want Google indexing all of it, because it's just a waste of their time, and it's gonna eat up their server RAM, because there's something accessing that constantly.
That's actually, I never thought of the idea of like preserving your own website resources and your own server resources. Because if something's being indexed, it's probably being read in its entirety.
Exactly.
And that's you sending out information, right?
And that happens, I would say, almost every company is indexed at least daily. That's publicly facing. And I would, and not just by Google. I mean, there's hackers scanning the internet. Shodan scans the internet. There's sites all over that just scan all day.
Right. Interesting. So, I mean, look, this is, my notes said, and this is where, this part 1, part 2, and part 3 are sort of easy, right? I've heard of the robots thing. So this was part 1. that's part two. And I mean, if you just go onto the website and you search for robots.txt, that's part three.
There's three.
And like, I think this is an Apache server. Can you access the next flag? And at this point, I was like, oh, dude, I have no idea. So I think I did some searches like, I'm trying to remember, like I searched something about how to check if it's an Apache server. How do I get Apache server information? But I had nothing. So at this point, I went down to the walkthroughs. So like, can you tell me a little bit more about this hint and like what exactly is going on?
The hint isn't necessarily to, especially with the way they're doing it previously, right? Is the hint isn't necessarily to look for something that Apache's hiding. It's to understand how Apache's directories controls are in place. So that they're looking for the HTA or htaccess file. And all that is in Apache servers that will specify the directories that so a website's just directories, right? It's just directory after directory, whatever. The htaccess file will tell that website how to handle those files. So it's just a configuration file in Apache. So it kind of follows theme with what they're looking for. I think the hint is just simply that it's an Apache file. Now, again, this is something, if you did a Dirbuster, GoBuster, any of that stuff, it would find all this within seconds. So this is all stuff that you would already know about. Yeah. And then there's another one. It's the hint is the Mac that it's on a Mac. Again, same theme. They're looking for you to do a little bit of research and find that MacBooks or whatever you want to call them, store stuff on a DS store file. This is, again, a configuration file to store attributes. That's it.
When you say attributes, configuration file to store attributes, like, I guess, what attributes and why is it used?
So the big one with websites, especially with directory structure, is, so let's say you're an admin on my site, right?
Yeah.
I want you to have access to more of that website than just Joe Schmo or a customer logging in or something like that. So I can control your actual directories and permissions and things like that, who can view them, stuff like that, from these configuration files. I can hide them from the normal people, make them not accessible without certain accounts, things like that, without permissions. So that's the big thing, is these control directories specifically rather than control the entire site. So it's just a way to control what files are able to be seen and accessed and how they're able to be seen and accessed. Because if you write a program, maybe I want it to load some pictures for me or something, but I don't want it to be able to, go log in and look at all the user accounts on the website, right? I need all that stuff separately, and I need the permissions to be separate as well.
Right. Well, I think this is actually, no, I love making websites on my Mac. And so the Mac one was called the DS Store.
Yep.
And interesting, why do you do .ds store? Is that dot at
because it's a hidden file. So if for those of you that don't know, Mac is just Linux. Mac was created from Linux. It's just now closed source, so it's not free anymore, and they shut it. They closed. But basically, on Linux, if you put a dot in front of a file, it hides the file. You're just missing the bracket at the end, I think. But yeah, so the dot in front of it just means that's a hidden file. So like if you just did ls, you wouldn't find it on a Linux server. But if you did ls-la or something like that, you would find those hidden files.
Right. It's, not nice of Mac. Like you take an open source project that makes a really, really efficient operating system. You do a couple of improvements, but now no longer open source.
Yep. Now it's ours, and now we're going to charge for it. Yeah.
Yeah. Not like very much not in a spirit of things. There was the original sort of, I don't want to go too far off topic, but I watched a documentary about sort of original days of I guess operating systems that that were developed, and what Bill Gates did by trying to buy DOS from a guy, and he was a part of this sort of programmer / hacker community that was developing tools, but he was in a constant argument over everybody, like, you idiots, you need to charge for this, you need to charge for this, we all need to charge for this. And they were like, no, it's digital information. It's easily replicable with a button. Why would we charge? This is what's so good about it.
Yeah.
Like, and I don't know. I think the truth is somewhere in between. I think if you're an expert in the domain, I think you should charge a lot for your time. I think programmers should be charging more than lawyers. But I think software itself should, to the extent that possible, be free. I don't know. That's just.
I agree. My biggest argument with people that say that shut it down is innovation comes from open source, in my opinion. I mean, if you allow 5 million people to look at one line of code, and let's say only 1,000 of them are coders, I'll bet you someone else finds something to do in there besides the coder to make it better. Because having different eyes on things makes things look better. In my opinion, makes more improvement. So I would rather take if I'm created something and see where people can take it rather than close it off. And then it's only going to go one route the way I want it to.
Yeah, no, I'm 100% with you. Eventually we could do some kind of, a chat or a video talking about more philosophical issues. But I overall, I'm fascinated with kind of like how genius inventions come about, particularly things that are like quantum leaps, like the advent of transistors or like information theory. And a lot of that just so much of that stuff is sourced in Bell Labs, which was this privately. So Bell, I'm going on a tangent, but it was a privately funded monopoly that threw basically virtually infinite money at geniuses who then just did their thing, collaborating freely with anyone around the world. People were constantly coming and going, and they were publishing everything they did. So it was nothing that was like private or top secret.
Yeah.
And that, in terms of engineering, was the biggest hotbed of innovation in the history of engineering. It wasn't a company trying to make a product or make money. It was just a bunch of really smart people with a lot of resources doing what they do. So
that's why, like, Google, I don't know how true this is nowadays, but at one point Google would let you would work half your day on what your job is, and then the other half you just get to use Google resources to then do whatever you want. And that's how a lot of Google's inventions were made. That's how a lot of their things were created.
No, like, I didn't even know that, but that's zero surprise. Okay, some assembly required. Now, like, I'm trying to remember. This one in my notes says this was damn near impossible. I had to look this up. So
this one,
take the lead, buddy, because I'm trying to even remember what this is.
This one I did totally different than the way you're supposed to do it. So we'll see what you're supposed to do. I'm not sure because, like I said, the way I did it is different. So let me load it up here. I just want to.
Let me inspect it.
Right.
I think here's where, I understood immediately that this thing was like. Do you see this? There's this JavaScript program that was done on one line. And while I am like semi-competent in JavaScript, I can certainly read it well enough. I mean, I've used JavaScript libraries to make little games that work in the browser and stuff like that. But just unpacking this was just so hard, and I couldn't do it. I couldn't auto format it in my IDE. I've seen some people that use VS Code have had success online. So once you unpack the script and have the code formatted, even then, I wasn't sure that like if I could do it. Overall, so just talk me through it. Take the lead on this one. I am a little lost.
Yeah. So let me get rid of the one I downloaded earlier. So this is, I'll screen share and I'll show you how I did it. Now, this is not the way they want you to do it. They want you to do what you're talking about, which is unpacking all the code and all that. That is not what I did. So
cool.
All right. So let me pull up the actual. Okay. So some assembly required. You can see there's no hints. The first thing I did, which is exactly the same thing that you were talking about, is I looked at the actual code and then found out that basically I got the same place you did. I was able to kind of make it look semi-normal, but then still there's so much to unpack. So I thought, all right, let's look at a different route. All I did was I copied it. I went to the website, right? Here's the website. And then I just went ahead and started capturing packets. Now, this is sort of breaking it down, but this is basically the reason I did this is because I wanted to see how the website works. I wanted to see what it's trying to do when you enter this flag, because sometimes, it wants a certain flag and it works, right? So you can try to manipulate it and things. So I wanted to see how it works. So I went ahead and did that. All right. And then we have intercept on. So we'll go ahead and forward it. And then we'll go ahead and forward it. And this is where I stopped, because this is where I saw this file that it's reaching out to. And I did not know what that file was, because that file was not listed when you look at the actual code.
Right.
So I went to history, and there's the JavaScript code that I think you actually see normally when you look at the code. So I saw that it's hitting this first. And I said, what is this? So just knowing how a website works, I know it's just a directory. So all I did was copy, and I just went to it to see what is on it. And it's a file. So I said, okay, let's save it and just open it up and see what's in there. So then and there's the flag right there at the end.
Nice.
So all I did was find that they were trying to access this file. I have no idea what they were trying to do. It's obviously encoded in some way. And then when I just catted it to see what the contents of the file are, since I don't want to open this file, I don't even know if I have anything to open it. There's the flag right there. So that's how I did it. Again, I know this is not the proper way, but this is just the way I found it. And it was easy for me to find based on just understanding how it works.
Well, I stumbled across it too. Again, I'll share my screen. At least your thing has a logical explanation. There is a chain. You request the website, and then it checks it. Like it sort of redirects from that folder. That means that it's when you send a flag, it is accessing the information from that folder. Correct. Which would give you a reason to look in. Whereas what I got to say is, if you look at this, I mean, I know how to find it. I was looking at what the website is made out of. So there was this one line thing that's hard to unpack. The index, there's nothing really there. And there was this file, which is all gobbledygook until you get to the end where the flag is, right? And
so that's probably the same file.
That's the same. I mean, that is that same file. You had a reason to look in, and I had a reason because there was nothing else I could see to look in except this. So I would strongly suggest that everybody watching this, follow Stuffy's method and not mine, because I had no reason to look in there except I had no understanding of the JavaScript file. So I was like, is there anything else?
Yeah, it's the same process of elimination, right? You did the exact same thing. You just didn't intercept it. You saw that was a file sitting there that you then were interested in seeing what's in it. So it's the same thought process behind it. It's just how you get there.
Let me ask you. Let me ask you a question. Have you ever come across like a legit website that has like JavaScript files purposefully terribly formatted? Like, does anybody do that as a security measure?
I've never seen it. I've never seen it purposely formatted that way. I've seen bad formats, but no, I've never seen anyone do that. It does have a name, obfuscation, but
right.
I wouldn't say that's actual obfuscation personally, because you're not really hiding anything. It's just misformatted. Someone could format that again. It'd take a little more time, but it would make whoever's job it is to edit that site in the future impossible. So I don't see a company doing that unless it's a small company and the guy thinks he's clever or something. But
okay, that's good to know. That's good to know, because I kind of want to spend my time doing things that lead to some understanding rather than trying to get that bracket in the right spot or the tab to format the code in a way that I might understand it. All right. So some assembly required is done. More cookies. Yeah. I think I skipped this one. So if you've done it, by all means, take over again.
Absolutely. Yeah. So all right. So this one, I can explain the process. I'm not going to, just for the sake of time as well, I'm not going to break down the script line by line, but I'll walk you through it. So, okay, let me get to it. It's called
More Cookies, I think.
All right. So yeah, you can tell this one's harder. 31% liked it, right? So, okay, so it says I forget cookies can be modified client side. So now I decided to encrypt them. Okay, we haven't got to the client side one yet. So first thing, I'll always do this. You'll notice me doing it all the time, is I just always go to the site first to see what I'm trying to deal with. Because sometimes you'll get on a site and it'll tell you the exact, especially if it's a default page, it'll tell you exactly what like version it's on and stuff like that. And I can use all that against them. So welcome to my cookie search page. Only the admin can use it. Okay, cool. So we've got that. So now, basically, all we're trying to do, let's see what the hints are. So here, this is a big hint, the homomorphic encryption. So the hint there is, if you know what homomorphic encryption is, obviously you can research it, but basically what it is a cipher blockchain. So remember how we spoke in the last video, how things can be XORed? Well, XORs can be reversed. Right?
Yeah.
So what we're trying to do here, it tells us here that you need to be an admin to use it, right? So if we go ahead and turn on our burp suite and we go ahead and refresh this, intercept it. All right. So we see instantly that we have a cookie already.
Yep.
So first thing I did on this is I copied it, and then I tried to go to CyberChef and de-encode it. It couldn't figure out the encoding, but I know it was base 64 encoded. So I de-encode it once. This is called a de-encapsulation attack. So what it is this is encapsulated so that you can't see it, right?
Well, I'm happy that up until this point we did exactly the same thing, right?
Yeah.
Because I thought like encrypted cookie, great. I'll take the cookie value and paste that into CyberChef. I'll try magic, and I got nowhere. So that's where I stopped.
De-encapsulation actually usually occurs if you've ever seen like a website that's like, it's got a web browser or a URL, and then it's got like 5,000 characters after it, right?
Yeah.
It's the same idea. You can take that out, de-encode it, change something in it, right? So we're trying to change to the admin account. So basically, long story short, if we de-encode this base 64, we get a result, which is still gibberish because they use homomorphic encryption. What this does is it uses a cipher blockchain that is XORed. So we can, if you remember how XORs work, it's going to be reversible. So we can flip the binary back, and that will give us the original code, basically.
Okay.
So all we need to do, because right now it's telling us that we're not admin. So somewhere in this code is admin equals 0, which means false, right? Admin is not true. We need to switch that to true. So what we use for this is a script and I'll have to see if the cookie's the same. So all right. So it does not look like the cookie is the same. So I will have to edit the script, which is fine. So we'll go ahead and edit this script. And this way we can actually kind of break it down.
Cool.
So this is a Python script. It's not my script. I will say that. Obviously, base64 import. So we're going to decode it decode it from base64. So first thing we have to do is we have to change this to our current cookie, which is here. All right. And then this TQDM, this is just a progress bar. That's all it's going to be. So it's just going to show us the progress as it's trying to flip each byte. So what this code is all going to do, to break it down for you guys, is it's going to go line by or byte by byte, and it's going to flip them. So if this is a 1, it's going to flip it to a 0. If this is a 1, it's going to flip it to a 0, vice versa. And it's going to do that the whole way. And all it's trying to do when it does that is get this admin equals. And when it hits that 0, it'll flip it to a 1. It will then think we're admin. So it's going to just keep flipping them one by one and sending the request to the website and see if it thinks we're admin. So,
that is so smart, right?
Yeah.
So like you reckon the request that's valid versus invalid is exactly the same. The only difference is between a single value that's a 0 or a 1. Yep. And a 0 or a 1 is basically, they'll be byte encoded. So it's
exactly. So you can flip it.
Oh.
Yep. So this code will just do that. That's what this script does. Like I said, I didn't write this script because there's better people out there to write the script for me. But
yeah,
I understand the concept completely. I would have done it manually and it would have taken me forever. So basically, so now we save this. Make sure if you do use this script, if you see it, or if we can put it in the link or whatever, basically you have to change the cookie. And then I noticed that these are different a lot of times too, the ports they use and stuff. So make sure you change that, but you'll see as we run it. So we'll clear that. And as we run, so we'll do the Python 3 test.py. And as we run it, you'll notice it's brute forcing bit by bit. And it will take a second because it is doing it bit by bit. And I'm running a bunch of stuff on my computers, but yeah, it'll go bit by bit. The progress bar is this TQDM import. So it will actually have a progress bar. It's a cool little feature that you can use if you're creating scripts and things like that.
Well, it's very necessary for any type of sort of brute forcing, because nothing worse than having like you've set up a Python script that's you think the algorithm's good, but it might take 5 minutes, but you're not sure it might take 5 hours. And if it takes 5 hours, you don't necessarily want to hang around.
Exactly.
Like some kind of a progress bar is
yeah, it's definitely important. And you'll see once it actually figures it out, because it's taking much longer now, but that's probably because I have Zoom up and everything else up than it was earlier. But you'll see it'll eventually find it and it'll pop out our flag, because what it's doing is it's actually trying to send the request every time too. So it's flipping the binary and then actually sending the request on. And then if we get, so you can see right here, it says print if picoCTF is in the text, print it. Otherwise don't. So basically what that means is it's not going to show us anything, but then as soon as it finds that picoCTF,
and it
will print the flag
and
for
break.
us. Yep. So I didn't mean to click that, but it will print the flag for us too, which is really nice. There, you can see it's starting to go a little faster. But
here we go.
Come on. But yeah, this is pretty much how it is. The problem is this is taking forever because this is only the first bit. But I think it's on like so there it's already finished 10% of it, but it's on the I want to say like 6th or 7th bit or something like that. Yeah, because you can see this script was only designed to do 10 bits. So whenever he wrote this, he only did the first 10 and it was able to break it in the first 10. So
this is I'm really curious. So you've done this essentially by instead of trying to break the entire code and figuring out the system of encryption, which seems impossible, you just realize that, well, whatever it is sending is literally 1 bit off from actually being the request that wins.
Partially, yeah. So
partially, I know you still needed to do the flip and
the key here was the homomorphic encryption, because that's what homomorphic encryption is it's you can basically, it's vulnerable to byte by byte attacks like this. So that's what gave it away to me. But what they did that made it harder the one that took me a little while is, if you notice here, it's base 64 encoded twice. So that's kind of the first thing that threw me off, was because I was like, okay, I de-encoded it base 64 and still got gibberish. And then I tried to do this and I was like, okay, that didn't work. So the fact that it was base 64 encoded twice made it a little bit more difficult, just because you don't necessarily expect it, right? You're just trial and error. But this is this homomorphic encryption isn't as common, but it is common to encapsulate and then encapsulate and then encapsulate in different encoding styles. That way you can send certain things like cookies or admin tokens and things like that across in plain text, even though it's encrypted, or not encrypted, I'm sorry, encoded. And that's what a de-encapsulation technique is taking all that and de-encapsulating it, deconstructing it, getting like the admin token and then changing it to a 1 and then re-encoding it the same way, so the server will understand what you're trying to do.
Can you, while we're waiting, do the paste bin for this and then send me the link for the paste bin? Because that was something that I'll try to put into the description. For
the actual script?
Yeah.
Yeah, I'll give it to you here, because I've got to actually find this exact one. I think it was a GitHub that I downloaded it from, but yeah, there's a bunch of them out there that can do the same thing. This one I just like because of the progress bar and everything.
Yeah, without the progress bar, it would be like a bit more.
Yeah, you might just sit here. But yeah, I'll get it to you here.
So it's done 5 out of 10, and now it's going faster. So like we probably like 3/4 of the way.
Yeah, I think this is the actual. I think it's on 6 or 7 for sure, but yeah, the other hint that they gave you, I've totally forgot to bring up. You might notice it. This is why I like sometimes they do this. You notice here, cookies B client is all capitalized. So CBC is cipher blockchaining. So the one thing, if you know encryption, cipher blockchaining can be reversed as long as it's just done once, right? I mean, if it does all of its different processes and stuff, it can still be reversed, but it's gonna be longer. But as soon as they gave me CBC, which is cipher blockchaining, I was like, okay, so you can reverse this because it's just XORed once, which is a bit flip is what it's called. All right. So here I've got the
and surely this is it. If we misconfigure this, then
it'll only go to 10 either way.
Yeah. Cool. Thank you for that. I will. I'll open and bookmark.
Maybe the cookies. Let me make sure I got the cookie in there right. QK. Yep, there you go.
Ah, there it is.
Cookies, so it's the ninth. Yum. It's the 9th one. So yeah, Pico's cookies yum. So yeah, the science behind it is very sound, right? It's very easy to understand if you can break it down correctly. It's more of having the Python knowledge to reverse the bits. But yeah, if you guys want to learn more about this specific attack, just look up XORing, because that's all it's doing. You're flipping the bit because the encryption method is XORing. So you're just reversing the encryption.
I need to,
but you're doing it on a byte level.
I actually have taken it in my notes to make a video on XORing. And
yeah, that'd be a good one to
just like in Python. And then, because I want to teach myself what that is in a more practical way. And so like picoCTF like had a bunch of functions that do some XORing. So I'll definitely look more into it. Okay, so can you send me that cookie? The flag. Send me the flag via chat. And because that's the only one that's technically unlocked here. Sorry, not unlocked.
They're kind of a pain because
you have to type it in. Is it like
I have to, only because I'm on a virtual machine, so I can't.
You can't paste out of it.
No, I make sure of that because that's how you can. It sounds like very paranoid, but I make sure that my VM cannot interact with my computer.
Right.
Because there are breakout techniques, but
that makes sense. And that's fair.
It's very rare. You'd have to be a very, very good hacker to break out of VMs, but there are hackers that can do it.
Wow. Cool. I have just for the, if you don't mind, I'll take over for a sec.
Yeah, absolutely.
And that's my screen. And you missed the more cookies moment when I pasted this and the challenge was solved. Let's jump back into it. So more cookies done. Where are the robots? 100 points. Points are going up. Can you find the robots? Okay. Is it just /robots.txt on this thing? Because
I don't know why this one's worth 100 points, but
robots.txt.
You can see though where to go from here.
Disallow. So that it's saying it doesn't allow that page. Yep. And disallow, is that like this is for the web crawler, right? Like
that just tells it can't, not to search that page.
Right.
So it also, go ahead. Sorry.
I mean, if I did this challenge, I would have put like 7 pages or something, right? Well,
yeah.
But yeah, cool.
Yeah. It also allows places like Google, right, to not waste resources because they're not crawling the entire internet. They're just crawling the domains that you would want to find in Google. So it helps Google and it helps you.
It's very interesting. Like, I didn't think that was symbiotic. I didn't see, like, when I first learned what robots was. I thought that was like something that purely Google did as a favor, and professional search engines like, okay, don't index this. And the Google was just willing to do it. But now that I think about it, it actually is a resource saver on both sides. Like it's good reason.
Yeah, it's a huge resource saver.
Okay, calculating machine BB4C. I'm pretty sure I unlocked it, but why not just... Okay,
there you go.
Let's look at Logon. So here's the challenge. And it basically says the factory is hiding things from all of its users. Can you log in as Joe and find what they've been looking at? So let's look at this. Now, one important hint, it doesn't seem to check anyone's password except for Joe's. So if you type in Joe and you type in some password, it will basically say super secure. If you type in some random username and any password, you're going to be in, but there's no flag though. So I think the idea here is we're going to get Burp Suite up and going. And we're going to capture the request where we're logging in as someone else. And maybe
you could probably just log in and then capture that packet and change it that way, rather than capturing it in transit.
So let's go into the proxy. Intercept is on. We'll open browser. Might take a second. That's the. I'm just going to forward that because that's the original website. And now we're going to log in as whoever. And it basically, here is the request. And if I changed, I mean, I'd prefer to send this to repeater.
Mm-hmm.
It says username is that admin is false. So if we set admin as true, maybe full screen just to make sure it's all formatted nicely. We send that.
You got to follow that redirect. And if we remember, there's a couple of them.
Okay, render. Bang.
There you go.
Now, the audience might not know because it's going to be edited out. This is the second time we're doing it.
Mm-hmm.
And we did exactly this thing. And it didn't work because I had used Burp Suite on 3-4 challenges. I've been messing around with scope. And somewhere in there, something went wrong. And frankly, it was easier to restart than to figure out what went wrong. So copy that.
Now, I saw in your notes, how likely is this in a real world scenario? I'll say it's not as likely to be as simple as admin equals true. That's uncommon, but it's not uncommon to try to do what's called session hijacking, which is, for instance, it's a similar concept. Instead of changing the admin equals true, I'll try and take your session ID and
like a cookie,
exactly like a cookie. Yeah. And I will insert it into my packet, and then I'm now logged in as you. So that happens quite a bit. That's why when you're dealing with real world hackers, they tell you don't even tell them what browser you use. And the reason for that is because if they can, so for instance, a lot of websites will do checks, right? So like if you try to insert that session in Firefox, but it was originally made with Chrome, it might be like, hey, that doesn't make sense. Versus if they use everything the exact same, they'll change their VPN to close to your address. So then the IP comes from the same place. They'll use your browser. They'll use everything the exact same. And then it's less likely to get flagged or caught. So that is a real world scenario. It's just not as simple as admin equals true a lot of times. And then some websites will use patterns. So like, for instance, if your login is, number 4735 or something, and we know it goes up by 1 every time.
Yep.
I can then change it to 4753 or whatever. And that's somebody else's login. That'll sometimes work. Again, that's simplified down, but it is possible to get logged in. This used to be a very big attack. This used to be very common.
Right. Okay. Like I'm noticing in the whole web exploitation, we've not needed the web shell at all. I mean, we've used curl, but we could have done without it. Okay, so we've done the logon. Don't use client side. And what is meant by client side here is the actual HTML code that is downloaded and used to display the website by the browser. Is that what they mean by client side? Those HTML, CSS, and JavaScript files that the browser uses to render the site.
It means your browser's rendering it or running that versus the server side, which would mean they're actually doing the work. Now, the reason it says don't use client side is usually client side means that I can manipulate it,
right?
And then send it to your server, which is usually not good, typically.
Let's have a look at the website here. This is a secure login in Portal. Enter valid credentials. It's just like a word. So incorrect password. Cool. But if we inspect, let's first see just the, oh, and look, there it is. That's the flag, but it's a terrible, so they have like a split, which is an integer, and they multiply it by 4. So they're doing it 4 letters at a time, and then they're checking like sections that are not even in order. So you can't even copy it in order. And like there is no good way to do this. It's just a tedious task. Like I can start something that looks like code, and then I can paste it into it. Where is my secure login portal? I mean, I was going to go to sources, index, and I was going to write a script, but that would have just taken longer than doing it manually. The reason I'm going to use Replit is I can like drag around lines, which helps. So let me show you. By the way, this is like tedious since the information's already there. It's just a question of getting it in order. So what's the order? It goes from 0, and then the next one's obviously 1, but you don't need a 1 because split is the same as 1 times split. Then the next one's a 2, and I'll drag that in there. So 0, 1, 2, and then we need a 3. And then a 4, 5, 6, 7. Oh, 4, 5, 5, 6, 6, 7, 7, 8. All right. So there it is. That's the pieces of the flag in order. All right.
Yeah. So this is why you don't allow client side, because it's validating its check on your machine. So it's relying on your web browser to validate this check. The problem is then you can bypass it because you can manipulate the code however you want.
I mean, if there was like a hash here, it would be safe-ish, depending on the actual, like if you're hashing something quite complex, like this flag has got a lot of characters and a lot of them are random, right? Would you say that a hash here would have been pretty secure if there was a hash on the client side?
I would say it depends on what the hash is for. So if I personally would say no, I would never put my hash web facing if I don't have to, only because you never know, even if it's the most secure algorithm in the world right now, you never know when an algorithm can get broken. And that does happen a lot. Someone figures out a way to crack it real fast. MD5 was known as secure for a long time. SHA-1 was known as secure. Everything was known as secure at some point. So you never know when someone might figure that out. And then that can become a 0-day attack, meaning that hacker might be the only one that's figured that out, how to crack it. And he could just take that hash and crack it.
That's very, I think the exposing hashes is sort of like something you should try to avoid and should be last resort
absolutely,
if possible. So back into my half screen view, I can see that we're going good. So now don't use client side was the 8 out of 10, and we're probably on schedule to finish everything. So don't use client side. It's my birthday.
So this one actually, as soon as I read the name, I knew exactly what it was. If you're not familiar, it's a concept. You'd have to look up the exact wording on it, but basically the concept is that if you put 100 people, this is just the numbers that I'm guessing. I don't know the exact numbers are off the top of my head, but if you put 100 people in a room, right? the likelihood, or I think it's way smaller than that. Maybe it's 5 people or something. I can't remember. But if you put them in a room, the likelihood that one of them will have the exact same birthday is very good.
Yeah,
right?
yeah. It's higher than your intuition would say.
Yeah,
right?
exactly. It's much higher than you'd think. So it's the same thing with I can't remember the name of the principle, but that's the principle behind it, is that a hash is the same way, is that you don't think that collisions would happen very often, but it's way more common than you think. And so this is known, I don't want to say it's a birthday attack, because a birthday attack actually is when you set a date for an attack to happen. But this is kind of a birthday attack where basically you're trying to get a hash recreated by putting in 2 different texts, right? So if you hash Stuffy, and then let's just say you used an algorithm that has a lot of collisions, and then you hash another word and it's the exact same hash, that's a birthday attack.
This is actually like, I looked this up, and the second the guy said that there are files with the same hashes, I like paused it and I figured it out.
Yeah,
I think it says MD5. There is a look at the category. How many? There's somewhere.
it does say
MD5 hash. So I just Googled 2 files or two scripts, whatever, same, and same like MD5 hash, and it wasn't much. MD5.
No, MD5 is still in use quite a bit. So
collision and added 2 known.
The big thing here is,
and this is the one. This is the one that I use.
Okay, so like what you're looking at here is so those are specific texts, right? So you got to think of how many files and things like that are in the world versus how big the hash can be.
Yeah.
The math is obviously exponentially out of my reach to do manually. But eventually you're going to have a collision unless you make that key or the actual hash itself way longer, right? Because that opens up possibilities.
Indeed. So I initially was looking at this page, and then I realized, like, exactly what last time we met, you told me something that like blew my mind. This is how you avoid tampering, because even if the content is the same, the metadata will be different. And I'm like, oh, I can't use that as PDF files. And then the least bad thing I could do was like hello and erase.exe. And I just downloaded them and changed them to PDF.
Okay.
And that's how I did it.
You can still download PDFs typically. Because the metadata doesn't change typically when you download them if you're not opening them.
Hash.
Because so the example I always like to use is, just because it's very famous, is you've heard of John Wayne Gacy, famous serial killer?
Yes.
So he got caught because of metadata. He submitted a floppy disk to them, and they went in the metadata and looked and saw that the owner is him, and it's registered. The license for the Windows Microsoft Word that he was using was registered to his church. So like, that's an example where he sent off the file, someone else opened it, but the metadata stayed the same. Yeah.
And like, that's very interesting. Like, yeah, it's John Wayne Gacy. Like, again, John Wayne, 3 letters. Yeah. There's something about like serial killer names. They tend to have, having a Christian name is common in the States, but like they tend to go by 3 names or something.
Yeah.
Cool. So yeah, that's how I did it. I could show you.
Absolutely. Yeah.
Where was those? This was it. It was hello. And so I just downloaded them. And this is a problem though. This could be a problem for a lot of people. Because downloading exes is something that a lot of antivirus programs are going to just stop.
Yep.
I guess
the easiest way I would say to do this, if you're having that issue, is do a little research, find some either some characters or something that has a MD5 collision, and just do it on your own. So what I mean by that is, let's say, the word hello, the string hello and the string erase have the same collision. In this instance, they're obviously files. But if you did that, you can then use MD5 sum on a Linux machine and hash them yourself, and then show that they have the same one. And then you can just turn them into, because I don't know what the, you can just change the extension like he is here.
Yeah. But it's because I did this already. Like, these are the files, and in the website, if we open in a new tab, I need to close all these. So yeah, I mean, I could choose. I'll do it off screen. I don't want to expose too much of my file system for whatever reason. The more I do this, the more paranoid I become. I don't know if that's a good thing or a bad thing, but there's one, and there's the other, and they're different sizes. But look, I get the script where it tells me the flag. So this is actually really, like, I think this is a great challenge. Might not actually have anything technical about it, but just the idea that there could be a collision of MD5 hashes is an interesting one.
And that's something hackers will take advantage of, that because there's a task called pass the hash, if you've never heard of it. So to like log on as someone else, I don't have to necessarily know your password. Sometimes the computer will take the hash because it still reads it. So even if I don't know your password, but I know your hash or can figure it out, sometimes I may be doing like a password brute force attack, right?
Yep.
And I don't know your password. I don't even get it right, but I get the hash right. That means the password that I found may not even be your password, but I can use it to log in because it's going to hash it the same way. So it makes your password. Sense. Yeah. It makes your password more vulnerable if you use a less secure algorithm as well. If there's more collisions.
And yeah, if there is even one collision, that's 50% more likely to be brute forced, right?
Exactly.
Interesting. Okay. So this last one for the day. This was interesting. I made a strong start on it. I thought I was going to solve it. And the way that it works is like, let me in. And it starts off, only people with the official Pico browser are allowed on the site. And when you capture the request in Hootsuite, so sorry, I keep saying Hootsuite because this is like the social media platform, like an automator for social media that I used for a bit. And but Burp Suite.
So the easiest way is just to do exactly what you're doing, intercept your initial
and user agent. And I just said, Pico browser. And I even use the same spelling, like Pico browser. So
first thing I would do after you do that is send it to a repeater, just because I know this challenge, we're gonna have to do this a few times.
Cool. I will action send to repeater.
And so one thing I noticed you do a lot, which isn't a bad thing at all, it's something I probably should do more, is you render the site a lot. I don't render it very often. A lot of times I'll just read the source code. That's something I should probably do more.
Yeah, well, I guess because I can't like instantly make sense of the the code, but I can definitely. I think I need to spell Pico browser with a capital P.
You got to send the packet. It doesn't automatically do it.
But I did.
Let's see. Oh, you spelled browser wrong. I didn't even notice.
Crossware. Jesus.
I didn't even notice.
Yeah.
All right.
And this is it. Like I just did the first step, and at this point, I was a little bit lost.
Yeah. So it says that it doesn't trust a user visiting from another site. So the first thing that pops to my mind is a referral site. So you want to put a refer in there, which is kind of like a redirect, right? So it's where you're coming from. So you can just put it doesn't really matter where necessarily, but you just put refer, and then
Like this?
yep, and then they always end with the colon like that. Yep, and then I just put the exact same thing. So mercury.picoCTF.net. I just put the exact same thing, and then if it works, you send it, and we'll see another option here. Yep. So now,
wow.
Yeah, now it only worked 2018. So this one,
like what?
This one,
Year?
I have an actual. I'll show. No, so you're gonna put date is the actual header. I have an actual date because I don't know if it'll check to see if the day of the year is correct.
Okay.
So you have to do date will be. Yep. You may have to capitalize it, but we'll see if it works. So I did the format Monday, so MON.
Uh-huh.
And then comma.
Oh, sorry. Yep.
And then 19.
Mm-hmm.
And then October, so OCT. And then I just did space 2018. And then just because I know how time servers work, I hit space and then 08 colon
08 or 08?
Yep. 08. Sorry, like 8 a.m.
Yeah.
is now we're specifying time. Now colon 00 colon 00.
Wow.
And then I just did GMT. It doesn't matter what time zone you choose. And then hit send. It may need.
That is.
Yep.
Oh,
so
wow.
So the all that is understanding the format of time. That's an easy lookup. So the whole point of this site is to look up the next step as far as like what you can do on a web browser. But so now this one, I don't trust users who can be tracked. So this one, I remember after I did it, I looked this up because I didn't find this. I didn't get this. So it skipped this for me and went straight to. So give me one sec. I didn't have to do this one for some reason.
Except encoding, decoding language.
Because it's driving me nuts because I remember
upgrade and secure requests.
What's this one called? Is it Who Are You?
Yeah.
Okay. So yeah. So that's what I thought. But like I said, I knew I didn't get this one, which I thought was really weird. But then I realized why I didn't get it. And that's because I'm not using the Burp Suite browser. I'm using Parrot OS, and Parrot OS is a secure, but you have to add the D&T header, which is at the top. It's do not track.
Okay.
And you'll have to just D&T and then just the binary 1 for true. Do not track.
Like that.
Yep. And I just realized that my browser must automatically add that.
Do that.
Yep.
Only for people from Sweden. Sweden.
Next. Yeah. So this one took a little bit. No. So this one took a little bit for me. Just because I had to look up IP addresses in Sweden. So
wow. Yes. So you did it that way.
That's the way I did it. I did so I did
let's see, Sweden IP range.
Yep. And I had to do a couple because the first couple didn't take. I don't know if they are just outside of whatever, but
major IP addresses blocks for Sweden.
Yep. So yeah, just take one. I can tell you one that works if not, because I did find one from Sweden. So you have to add the
IP like that.
Nope. You have to add the X TAC forwarder or forwarded. I'm sorry. Oh no, I'm sorry. The TAC, the little dash that I call it the TAC. Yeah. So it's X forwarded.
Yeah.
And then another dash after forwarded and then 4. So this is what a proxy would add to.
Yeah.
So forwarding 4, FOR, not the number. I'm sorry.
Yeah.
Yep. And then the colon and then whatever IP, and it may take that one. Like I said, I had some trouble with it taking some of them. Okay. So it did take it. Only for who use the official Pico browser are allowed. Wait, no, what happened?
It went back to the start.
Now go back to 1 up top there. Did we start a new one? No. At the very top, you have 1 and 2 at the tabs at the top.
Oh,
See if we.
no. We are on the right one. You're in
Okay, we are
Sweden,
on
but
the.
you don't speak Swedish.
Okay, yeah. So just okay.
Language?
Yeah. So this one you will see a lot of this actually on in some packets. So this one is the last one, I think, but it's so you're gonna type accept dash language. This one you do see actually a decent amount. So then the colon.
I just Googled something and I saw that. Ha.
Oh, there you go. Yeah. So you didn't even have to do all that. That's just a translation back.
Yeah, I literally Googled. Look, it's silly because they even got
Sweden
a localization error, and it's wrong because this renders it wrong in Chinese. But I'm like, whatever. This is definitely is definitely an HTTP request language. Why don't we have a look?
No, that's perfect. Yeah, you just got to get it to think that you're Swedish, basically.
Wow.
I can tell you, I've messed with headers a lot. I've never seen a site that would ever request that you were in a different year. That's not typical.
No, this was well and truly. No, the second. I'm trying to remember the second request because that one, like,
the second request was the referrer, so it had to be referred from itself.
Right. I don't trust people visiting from another website.
Yeah. And so that's actually not uncommon. If you have your site referencing each other a lot, you'll get that refer. But it just depends on what the site is itself. But sometimes that does help initiate trust, if you will, if there's certain files and things that you need to access, but it needs to be coming from the site, that type of stuff.
Well, we are done for the day, everyone. We're going to continue next week and we'll do pretty much the next 10. I think that we can systematically complete the web exploitation. Maybe not the 10. If I find it particularly difficult, we might do like 7 or 8. And when it comes to the ones that are 400 or 500 points, that will be interesting and a matter of seeing what happens in a couple of weeks. I think that we will either complete roughly some amount over half and move on to a different category, or we're going to see if we can go all the way with that web exploitation. Being someone who's sort of grounded in general computer science knowledge, if this flies well over my head, I'm not going to try to put an audience of people who are supposed to be people starting out. I mean, that's who we're aiming these videos at. So yeah, ladies and gentlemen, I'm your guinea pig here. And if I could figure them out on my own, we're going to cover them. Otherwise, we'll do something like cryptography, perhaps.
Yeah.
Thank you very much for your patience. Hope you enjoyed it. And we'll be back in a week. Bye.
Thanks, guys.